Good morning, guys. This is Joy again. This is Indices Part 2. Okay, so we'll be talking about. I want you to listen very well and try to, go through exactly what I'm saying because we are going to talk about continuation of laws in indices. Okay, so that by the time we see questions related to them, so we'll be able to split them and we'll know what to apply at any point in time. Okay, so now in indices part two, the we've done first one and second one, which is the multiplication law, and then I've been able to introduce one or two questions that you could see under those two laws. But we also have what we call power law. Okay, power law. Okay, and I told you that power is also the same thing as what? Index. Okay, so power law. An example, if you have a raised to power b and everything is raised to power c, that is power law. So the law says that you should multiply the power bc, that's b times c. Okay, that is bc is the same thing as what? B times c. So before you arrive at bc, we can say b times c, which is a raised to power bc. Okay, so that is that. So it means that is power law. Power law, don't forget. And I use a figure here to represent it. So we have 3 raised to power 4. Okay, all bracket raised to power what? 2. Okay, so it means that you should write 3 raised to power 4 two times. Why this power law is very important is that I can say 3 raised to power 4, everything raised to power 15. Okay, if I say everything raised to power 15, it will be cumbersome for you to be writing 3 raised to power 4 in let's assume it's 15. So it will be cumbersome for you to be writing 3 raised to power 4 in 15 places. 3 raised to power 4 times 3 raised to power 4 times 3 raised to power 4 times 3 raised to power 4 in 15 places. So it will take a lot of time. So that is why the power law is there to be able to shorten that process for you. So in this case, I just represent it with 2. Okay, so in mathematics, under indices, they didn't expect you to write it either in 15 places, either in 2 places. But for the sake of explanation, that is why you see that I did it like this. So it means that I should write 3 raised to power 4 two times. 3 raised to power 4 times 3 raised to power 4. Okay, so which is also the same thing as 3 raised to power 4 here. It means I should write it in 4 places. But don't forget, let's assume this one is 10. So are you going to be writing 3 times 3 times 3 times 3 in 10 places? You are wasting your time. Okay, for those in the jam class, they don't need all those. All they just need to do is just to multiply the power. Okay, if you even if you're in SSC or perhaps you're in GC or thereabout, or in the exam class, you don't need to be writing. And so the mathematics teachers already know that, okay, there's what we call power law. Just introduce power law to be able to get your answer. But for the sake of explanation, 3 raised to power 4 means you should write 3 in 4 places. That is the meaning. Okay, because all these ones are raised to power 1. I've told you anything raised to power 1 is that thing. Joy raised to power 1 is joy. 3 raised to power 1 is also 3. So if you don't forget, from the multiplication law, I pick 1, 3. Okay, I have the power 1 plus 1, 2 plus 1, 3 plus 1, 4, which is the same thing as this. So they are interrelated. Those laws are interrelated. So now, look at this now. The second one, which is 3 raised to power 4, is also the same thing as this. So from the multiplication law, which is the what I mentioned, the first law in indices. So I pick one base, okay? I pick one base and add the power. You can also multiply, which is 4 times 2 straight, 3 raised to power 8. But for the sake of explanation, 3, I pick one base, add the power. So multiplication law says that you can multiply it and get your answer, which is what? This one is the same thing as saying, I can come here and say this one is the same thing as saying 4 times 2, which is the same thing as what? 3 raised to power 8. That is what we call power law. This one is just for the sake of explanation. This one is the same thing as just saying, the same thing as 3 raised to power 4 raised to power 2. That's that. So now that is all about power law. Okay, please note all this law because subsequent questions that will be dropping, okay, we combine all these laws. It could be multiplication, division, and everything will come together like that. So the same thing applies. Look at rule 4, product power law. Product power law. What does product power law means? If you have A and B, they are different alphabets, all raised to power C. So it means that power will take A, that power will also take B, which is the same thing as A raised to power C times B raised to power C. Okay, the same thing applies. You can have different value here. Okay, A, B, C, all raised to power D. Product power law says that distribute the power across, which is A raised to power D times B raised to power D, B raised to power D times C raised to power D, ABC within the brackets. The same thing applies if you have figure, okay, within the bracket, which is 7, MB. I've told you, it's not compulsory that you see X all the time. You can see K, you can see N, okay, you can see L, find L, but most times you see X, okay? But in this case now, I'm using 7MB, all raised to power 2. So all I just need to do, distribute this power 2 or this index 2 to all the value within the bracket, which is 7 raised to power 2 times M raised to power 2 times B raised to power 2. Okay, so that is that. Now, if you look at the example I have here, those some of the questions that I've shared under multiplication and division law, you will see something like this. Very simple, just like chin chin and pure water. Let's assume for this power law now, okay, the example, you have 9 raised to power 2x. 3 times 3 will still give you 9. So it's something as saying 3 raised to power 2, 3 raised to power 2, all into what? 2x. So don't forget, power law, multiply the power, which is what? 3, 2 times 2x, which is the same thing as 3 raised to power 4x. It's as simple as that, okay? Very, very simple. Now, if you look at this one very well now, 4x, yz, all raised to power 3. This is product power law, example under product power law. So if you look at this very well now, I will distribute these 3 across the value within the brackets. 4 raised to power 3 times s raised to power 3 times y raised to power 3 times z raised to power 3. It's as simple as that, okay? Just know that we have power law, we have product power law, okay? For product power law, all the value in the brackets sometimes, most times, will not be the same. All you just need to do, distribute the power across. So the same thing applies here for 2mkn, all raised to power 5. Okay, you have 2 raised to power 5, m raised to power 5, k will also take his own raised to power 5, n will also take his own raised to power 5. So this is just to simply explain what we mean by product power law. Very important. Look at this number 5 law now. Zero power. We all know this one. I've mentioned it before. Even in the third part, I've mentioned it. Even in the, what's it called now? I've mentioned it severally. A raised to power 0 is equals to what? 1. B raised to power 0 is equals to 1. So in this case here, we have 0 power. Okay, I've said it. Joy raised to power 0 is equals to 1. 1000 raised to power 0 is equals to 1. B raised to power 0 is equals to 1. A raised to power 0 is equals to 1. If you remember, one of the questions I shared in the after multiplication and division law, I wrote something like 1 over 8. Okay, look at this one here. Don't forget, I said anything raised to power 0 is equals to 1. I can also write the same thing as, I can say 8 raised to power 0 over 8. It's the same thing. So it means that my 1 here is the same thing as 8 raised to power 0. Anything raised to power 0 is 1. It's just like simple. It's just simple logic. Just understand those laws. So it means that instead of me writing 1, I can write 8 raised to power 0. It's as simple as that. And I can apply division law here. Very simple. So, and I give an example here. Look at it. I intentionally dropped this here. That's 8 raised to power 0 is equals to 1. Okay? That is, if I don't want to write 1, I can write 8 raised to power 0. It depends on the value that is there. Sometimes you might see 2 here. You might see 1 over 2 in indices. 1 over 2. So here you can just say, okay, if you want to write this one, the same thing as 2 raised to power 0, it will still give you 1. Okay, just for you to have the same base, the same base, the same base, the same base. Okay, so look at this one too. 2 raised to power y minus 1, all raised to power 0 is also equals to 1. Okay, anything raised to power 0 is 1. That is 0 power law. Okay, then we also have what we call negative index law. Negative index law is very, very key. A raised to power minus b is the same thing as what? 1 raised to power a raised to power b. Okay? A raised to power minus b is the same thing as 1 over a raised to power b. Then the same thing, c raised to power minus d is still the same method. Then using value, 2 raised to power minus 3 is the same thing as 1 over 2 raised to power 3. So if I want to do it here now, I can change this one based on what I just mentioned in zero power law now. I can change this one here. I can change it to 2 raised to power what? 0, which is still the same thing based on what we have as zero index law. So they are interrelated. Those laws are interrelated. So 1 raised to power 2 raised to power 3, I can change this one to 2 raised to power 0, which is still the same thing as what? 1. The same thing applies here. 5 raised to power minus 6 equals 1 over 5 raised to power 6. And I give an example here. 1 raised to power 8, okay, is the same thing as 8 raised to power 0, which is the same thing as 1 here. 8 raised to power 0 is the same thing as 1 here, okay? Then over 8. And I've told you, most of the time when we write values in mathematics, they are raised to power 1. But anything raised to power 1 is that thing. So I didn't want to mention it. Now, if you look at this one, this is 8 raised to power 0 divided by 8 raised to power 1. Division law. I've told you in division law that take one base and subtract the power. So this is something as 8, 0 minus 1. So 0 minus 1 will give you what? Minus 1 if you press your calculator. Okay, that's 8 raised to power minus 1, which this one now, if you look at this one now, this one still fall back to what we have as an example here. So in this case, my A is what? Base, which is 8 here. Okay, my B is what? 1, which is the same thing as 1 over, you know, 1 over 8. It's as simple as that. So all these things, you need to note them and in the laws of indices. The last one that we have here is the root power, law. Okay, root power law. The root can be half, it can be 1 over 2, it can be 1 over 2, it can be 1 over 3, it can be 1 over 4. Okay, power index law, 1 over 2, 1 over 3, 1 over 4. We don't want to waste our time on these laws, okay, but they are very key. You just need to know them if you want to, if you want to perform very well in indices. Okay, so it's not a rocket science. They're all guided by laws. So power index could be half, it could be 1/3, it could be 1/4, it could be 1/5, it could be so. Now, if you look at this, I had to use this as a general one to represent it. This is the base, and this is the root power or index. You can also call it index. It can be 1 over 2, 1 over 3, 1 over 4, 1 over 5. Okay, so in our next class, we'll try to give example on root power so that we can proceed from there and see how we can play around with as many questions as possible under indices, because don't if either we like it or not, this comes out in SSC, it comes out in GCE, both in the theory objective, you see more than enough of them. Okay, and also comes out in them in either post UME or in jam class, and then a lot of them comes out in the question. So you need to pay attention to those laws because they are simple and they are straightforward. That was why I took my time to bring them out so that you can see how those things, how those laws are related to each other. So in our next class, we'll be able to buttress on few examples under root power. Then we can touch base on the maybe one or two more law. Then we can continue to solve the questions maybe we've shared later, or another questions in the past questions, so that we can understand it better. Thank you very much. Cheers. Ensure to please like, comment, and share so that it can reach a lot of young minds that are having challenges with mathematics, so that for them to see that we brought mathematics to their comfort zone. All they just need to do is just to get a phone and internet, let them just sit down at their comfort zone and listen to it and follow it step by step on how we've mentioned it, so that they can get the best out of math, and for them to see that mathematics is interesting and it's simple and you have fun while you're doing it. Thank you very much.